In this video, we'll cover solving polynomial equations. A polynomial equation is an equation of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1x plus a sub 0 equals 0, where this expression that's on the left side of 0 is a polynomial, right? A sub n x to the n plus all the way through a sub 0 is a polynomial whose degree is n, and these a sub I values are just real numbers where a sub n is not 0 and n is a natural number. Here are some examples of polynomial equations. In fact, you've already done some. Like 2x plus 5 is equal to 0. Right? 2x plus 5 is a polynomial of degree 1, so that was a linear equation. 3x squared minus x minus 4 is equal to 0. That's a quadratic equation, but the 3x squared minus x minus 4 is a polynomial of degree 2. The degree of the polynomial indicates the number of solutions of the polynomial equation, including repetitions. And I also need to add these include the real and imaginary solutions. So let's look at 3 examples. I have the equation. We'll identify the degree of the polynomial, the solutions of the equation, and how many solutions that equation actually had. The equation 3x minus 9 equals 0 has a polynomial of degree 1, because that is the largest exponent on the variable. We can solve it by adding 9 to get 3x equals 9, and then dividing by 3 to get x equals 3. So there is just one distinct solution of that equation. So as we've seen before, right, a linear equation has one solution. There are certainly exceptions to that, ones that were contradictions and identities, but otherwise there's a unique solution. X squared minus 9 equals 0 has degree 2, right, the polynomial has degree 2. To solve this, we can apply the square root property, add 9 to each side to get x squared equals 9, and then apply the square root property that says x is equal to plus or minus the square root of 9, or plus or minus 3. So there are 2 distinct solutions, negative 3 and 3. And this next equation, x cubed minus 9x squared equals 0, this is a cubic equation. It has a polynomial of degree 3. And we will actually focus on solving this equation in this section, but we're going to solve it by factoring. There's a common factor of x squared, and when I factor out the x squared, I'm left with just x minus 9 equals 0. And then I can set each of those factors equal to 0. So either x squared is equal to 0 or x minus 9 is equal to 0. To solve x squared equals 0, we can apply the square root property, which says x equals plus or minus the square root of 0, or plus or minus 0, which actually is just 0. And then, of course, we get x equals 9 for the other equation. So it looks like there's only 2 solutions, the 0 and 9, but the 0 is actually a repeating solution because of this plus or minus. So when we say that the equation has the number of solutions as indicated by the degree, that includes repetitions as well. So let me just recap here that we had a linear equation of degree 1, quadratic equation of degree 2, and then a cubic equation has a polynomial of degree 3. To solve a polynomial equation, we will set one side of the equation equal to 0, and then we will factor the polynomial until all factors are linear or quadratic. Then we will solve the equation by applying the zero product property that states we set each factor equal to 0, and then solve the resulting equations. Let me make a disclaimer here that in this particular section that we're going to cover, all of the equations can be factored, at least initially. Once you get down to the quadratic factor, you might have to use the quadratic formula, but initially they can be solved by factoring. we will not cover what to do when they don't factor. There is a method to do that, but we won't cover that in this particular course. So here are some examples. We want to solve the equation 4x cubed equals 100x. So we would first say this is a polynomial equation. The degree is 3. I need to first subtract 100x to get one side equal to 0. Therefore, we get 4x cubed minus 100x equals 0. We look for a common factor, which there is one. Both 4 and x divide each of those terms. So when we factor out the common factor of 4x, we're left with x squared minus 25 is equal to 0. Now, if you want to factor x squared minus 25 as a difference of squares, you may, but we could also set each of these factors equal to 0. This gives us 4x equals 0, or x squared minus 25 equals 0. Divide by 4 in the first equation to get x is equal to 0. To solve x squared minus 25, we can apply the square root property. So to apply the square root property, we get x squared equals 25, or x is equal to plus or minus the square root of 25, which is plus or minus 5. Our solution set then is, in order from smallest to largest, -5, 0, 5. Another example of a polynomial equation is 2x cubed plus x squared minus 18x minus 9 equals 0. This polynomial has degree 3, but it also has 4 terms. So to factor a polynomial with 4 terms, we will use grouping. We pair together the first 2 and the last 2 terms of the polynomial. The first two, 2x cubed and x squared, have an x squared common. When I divide out by the x squared, I'm left with, in parentheses, just 2x plus 1, right? X squared into x squared is 1. Then negative 18x minus 9, there is a negative 9 common. I always want to factor a negative GCF if the negative is leading in those terms. When I factor out a negative 9, that leaves a positive 2x, and negative 9 into negative 9 is plus 1. And then this is equal to 0. Now this is still not factored because I have a minus 9 in the middle, but there's a common binomial that I can factor out, and that's left with 2x plus 1 times the x squared minus 9. And now I have this polynomial in factored form. I can set each of these factors to 0 since I have a linear and quadratic factor to get 2x plus 1 equals 0, or x squared minus 9 is equal to 0. So I can subtract 1 to get 2x equals negative 1, and then divide by 2. So x is negative 1/2. Or I can apply the square root property to get x squared is equal to 9. And so x is equal to plus or minus the square root of 9, or plus or minus 3. And remember, in each of these instances, I can plug those values into the original equation to see that it makes a true statement. In order from smallest to largest, my solution set would consist of -3, -1/2, and 3. Example C is x to the 4 minus 13x squared plus 36 equals 0. So this is a polynomial of degree 4. I need to factor. It is a trinomial, so I will factor by trying to find the factors of x to the 4, which are x squared times x squared. Then I need the factors of 36, whose sum is -13. And that would be -9 and -4. Now again, I could factor these further because they are both difference of squares, but I could stop here and set each factor equal to 0 since those are quadratic factors. I get x squared minus 9 equals 0, or x squared minus 4 is equal to 0. Applying the square root property, x squared is equal to 9. So x would be plus or minus the square root of 9, which is plus or minus 3. Or x squared is equal to 4, which gives us x is equal to plus or minus the square root of 4, or plus or minus 2. So in order from smallest to largest, I would have negative 3, comma, negative 2, comma 2, comma 3. Then example D is 3m to the 4 equals negative 3m. So this is a polynomial equation, degree 4. I need to first add 3m to each side to get 3m to the 4 plus 3m is equal to 0. This is a binomial that has a common factor of 3m, so I can factor that out. And when I do that, that leaves m cubed plus 1. Therefore, 3m times m cubed plus 1 is equal to 0. Now I need to factor m cubed plus 1. And this is going to take you back if you need to look at those prerequisite skills on factoring. But m cubed plus 1 is the sum of two cubes. And the sum of two cubes has a factoring pattern. A cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. To remember the signs, I use the acronym SOAP. The first sign is the same as the original binomial. Then I have to take the opposite, and the last sign is always positive. So same, opposite, always positive. Well, what goes in the first binomial are the expressions that you have to cube to get the original terms. So to get m cubed, I have to cube m. To get 1, I have to cube 1. And then I obtain the trinomial by this rule. I square the first, so m squared is m squared. To take the opposite sign, which would make that negative, and then multiply m times 1, which is just m. The last sign is always positive, and I have to square the 1, which I get 1. So I can write this as 3m times m plus 1 times m squared minus m plus 1 equals 0. Now I can set each of my factors equal to 0. So 3m equals 0, or m plus 1 is equal to 0, or m squared minus m plus 1 equals 0. Dividing by 3, I get m is equal to 0. Subtracting 1 from each side, I get m is equal to negative 1. And then I have to solve m squared minus m plus 1 equals 0. The problem is this doesn't factor because there are no factors of 1 that add up to be a negative 1. So I have to use a quadratic formula or some other means to solve this. So I would say that m is equal to, you remember, the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So m would be the opposite of, our b value is this coefficient of m, which is negative 1, plus or minus the square root of b again, which is negative 1 in parentheses squared, minus 4 times a is 1, and c is 1. And that's all divided by 2 times a again, which is 1. So m is equal to positive 1 plus or minus the square root of 1 minus 4 divided by 2. And that's 1 plus or minus the square root of negative 3 divided by 2. And just remember that we can simplify the square root of negative 1 as I. So we really have 1 plus or minus I on the square root of 3 divided by 2. So this represents two imaginary solutions, and then we have two real solutions from negative 1 and 0. So our solution set would be negative 1, 0, and then 1 plus or minus I on the square root of 3 divided by 2. And then just one final thing I want to close with here is that the factor theorem applies if x minus r is a factor of a polynomial p, then r is a solution of the polynomial equation p equals 0. Why don't we just solve that? If we can write a polynomial as x minus 3 times x minus 2 times x plus 4 equals 0, and then by the zero product property, we know that we can set each of those factors to 0 to get x minus 3 equals 0, so x is equal to 3. X minus 2 is equal to 0 gives us x equals 2. And then x plus 4 equals 0 gives us x is equal to negative 4. So if we know that r is a solution, right, so if we knew that 3, 2, and negative 4 were solutions, that told us that x minus 3, x minus 2, and x minus negative 4, which is x plus 4, would be a factor of the polynomial.